Alrighty, folks. Today we're going to continue our look at circuits by moving on to parallel circuits now. Big thing. Series circuits offered a single path with which to travel. Parallel circuits are going to offer multiple different paths, which we'll refer to as branches, to send current through. Where this ends up being different from a series circuit. Because remember, in series, that current had to flow one continuous path, right? There was no other way for it to go. So wherever you were at in that circuit, you were always going to see one current. But now, if you look in this diagram in the bottom right, now we are set up in parallel. And it gets its name because when we draw out the schematic and when you physically wire it up, you can make those resistors physically be parallel. And that's what we look at here. So like R1, R2, and R3 are all running parallel to each other in the circuit diagram. What this demonstrates to us then, if you follow the arrows through that diagram, what you see is that current is going to get to point 7, 6, and 5. It's going to get to what are called junctions. And at that junction, that current is going to split. This means that R1, R2, and R3 can and do have different amounts of currents if their resistances are different. So for example, if R1 has a higher resistance than R2, you're going to see less current down R1 and you're going to see more current down R2. So if there's a greater amount of resistance down a branch, it's going to draw less current. If two branches have the same amount of resistance, then those two branches will draw an equal amount of current. And we can judge the amount of current that it's going to get based on the total amount of current that's present through the circuit. So let's say as we go from the negative terminal to the positive terminal on the battery, that current is going to leave that negative terminal of the battery, get to junction 7 there, and that current has a choice. It can either go along the branch where you have resistor 1, or it can continue going. Some of that current will then get to junction 6, where it has another choice. Will it go along R2, or will it move along to R3, where the remaining amount of current will end up going? Once that current goes down a resistor, it cannot turn around and kind of start snaking itself through. That current makes a loop, and that's it. It can't make a loop here and then kind of snake and then come back through. Once it makes a choice, it has to go right back to the battery once it passes through that branch. So that means from junction 8 to junction 7 on the diagram, because that has yet to go through any resistance, that is the total amount of current that's going to pass through the circuit. And that's the same thing between junctions 1 and 2, because all of the current that's present between junctions 1 and 2 has already passed through the circuit. And because it's passed through the circuit, there's no other resistance for it to go through. That is again going to represent the total amount of current that's present. What you really need to think about here is a path of least resistance. And this is where we start to see that concept. Where you have the path where there is less resistance, you are going to see more current. That doesn't mean that the one with a higher resistance sees no current, because that's not true either. If you have higher resistance, you still have some current flow. You still have some electrons choose that path. Not every electron chooses the path of least resistance. Because of this, each junction has the exact same amount of voltage going down it. So let's say, for example, our battery on the left-hand side of that diagram, let's say that's a 9-volt battery. Well, down resistor 1, we're going to have 9 volts. Down resistor 2, we're going to have 9 volts. And down resistor 3, we're going to have 9 volts. Each of them get the same amount of voltage. So now if we think back to Ohm's law, we've got the same voltage with a different resistance. It's going to draw a different amount of current. What's great about a parallel circuit is, let's say somehow between 7 and 6 there on the diagram, let's say that broke. Resistor 1 is still going to operate. That's still going to draw current, and it's still going to function. Now let's say just resistor 1 malfunctioned, and resistors 2 and 3 are fine. Well, now that current's going to split between R2 and R3. And what, again, that does is it lets us see that, hey, this part broke. We have a different path for this current to travel. Thus why it's significant that we can use these multiple paths. And that's where series circuits were different. If one of them malfunctioned, the whole thing shut down. In a parallel circuit, that's not the case. Right? You can have one thing break down, and now we're going to still see the rest of the circuit is going to function. The way that we then go about calculating these, resistance is tricky. Everything is reciprocal. So it's 1 over the total resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. Everything is a reciprocal. I cannot stress that enough. So let's say your resistors were each 10 ohms apiece. So you would have 1 over 10 plus 1 over 10 plus 1 over 10. To find the total resistance, you would have to take the reciprocal of that sum. Now for current ends up being nice. Unlike a series circuit, where a series circuit, the current was the same everywhere, for a parallel circuit, you're going to find, hey, how much current is flowing through R1? How much current is flowing through R2? How much current is flowing through R3? When you total that up, you get the overall amount of current for the entire circuit. Last but not least, on the bottom right here, the voltage change, or again, the voltage drop. Each branch is going to get the same amount of voltage. Each branch. Now, let's say you've got, something different set up where you've got 2 resistors on one branch. Well, then they're going to split that total voltage. But across each individual branch, across each path. So let's say you've got, 3 paths that the current can take. Those 3 branches are all going to get the exact same amount of voltage, and it's going to be the voltage coming from that battery. If you have 5 branches is going to tell you that we've got that same voltage down all 5 branches. So there's your summary on parallel circuits. This practice right here, this is excellent practice to, again, be able to go through, test how well you understand what's happening, both in terms of the math and in terms of some of the concepts. Things to consider, our resistors are still measured in kiloohms. And then think back to your concepts. We have different amounts of resistance. Now we're going to draw different amounts of currents down each branch based on the voltage that we know is going to be down each branch. As you have questions, write them down and let us know. Otherwise, enjoy the day, everybody.